The National Electrical Code, or NEC, addresses requirements for securing conduit. Let's review relevant articles. Article 358 pertains to electrical nonmetallic tubing, or ENT. Section 358.30b states that ENT shall not be used where subject to physical damage. Section 358.30c states that where subject to physical damage, ENT shall be protected by a rigid metal conduit, IMC, or intermediate metal conduit. Article 362 addresses rigid metal conduit, or RMC. Section 362.24a3 states that unless sealed with a listed sealing fitting, RMC shall be securely fastened to the building structure within 3 feet of each box, cabinet, or fitting. Article 366 pertains to electrical metallic tubing, or ENT. Section 366.22 states that ENT shall not be used where subject to severe physical damage. Section 366.22b states that ENT shall be securely fastened within 3 feet of each box, cabinet, or fitting. Article 370 addresses flexible metal conduit, or FMC. Section 370.30c states that FMC shall be installed only where the likelihood of physical damage is low. Section 370.42 states that FMC shall be securely fastened within 3 feet of each box, cabinet, or fitting. Consider these recommended practices for manufacturing settings in addition to NEC requirements. Firstly, use the proper type of conduit. Use conduit rated for the specific environment and type of electrical circuit. Secondly, provide physical protection. Provide additional protection, such as rigid metal conduit or floor boxes, where the conduit is exposed to potential damage from equipment, vehicles, or foot traffic. Thirdly, provide continuous support. Secure the conduit to the floor or wall at regular intervals to prevent sagging or movement. Fourthly, avoid sharp bends. Maintain proper bending radius to avoid damaging the conduit or electrical conductors. Fifthly, ensure waterproof and dustproof characteristics. Ensure the conduit is sealed with the appropriate fittings if exposed to water or dust. Sixthly, use warning labels. Label areas where conduit is present in the floor to alert personnel to its location. Regular maintenance is also critical. Inspect the conduit regularly and repair any damage promptly to prevent electrical hazards. In summary, the NEC provides minimum requirements for conduit installation. Supplemental best practices enhance safety and reliability in manufacturing environments. Consider the environment and potential hazards when selecting and installing conduit. Proper support and protection are essential to prevent damage and maintain the integrity of the electrical system. Regular inspections and maintenance are crucial for identifying and addressing potential issues before they become hazardous. The NEC provides guidelines based on the type of conduit. ENT is generally suitable for dry, indoor locations where it is not subject to severe physical damage. RMC is suitable for both indoor and outdoor applications, providing excellent mechanical protection. FMC is often used for connecting equipment where flexibility is needed, but it is less resistant to physical damage compared to RMC. ENT is a flexible, non-metallic tubing often used in walls and ceilings, but it should not be used where it is subject to physical damage. Choosing the right type of conduit depends on the specific application and the level of protection required. In manufacturing environments, where conduit is often exposed to heavy machinery, equipment, and foot traffic, RMC is often the preferred choice due to its durability and resistance to physical damage. However, depending on the specific location and the level of risk, other types of conduit may also be appropriate. When running conduit along the floor, it is important to provide additional protection to prevent damage. This can include using rigid metal conduit, installing the conduit in floor boxes, or providing barriers to protect it from equipment and foot traffic. Securing the conduit properly is also important to prevent it from moving or sagging. This can involve using conduit straps or clamps to attach the conduit to the floor or wall at regular intervals. The NEC requires that a conduit be securely fastened within 3 feet of each box, cabinet, or fitting, but in manufacturing environments, it may be necessary to provide additional support to ensure that the conduit remains secure. Avoiding sharp bends in the conduit is also important to prevent damage to the conduit and the conductors inside. The NEC specifies minimum bending radii for different types and sizes of conduit, and it is important to adhere to these requirements to ensure that the conduit is not damaged during installation. Maintaining a proper bending radius also helps to prevent the conductors from being damaged or stressed, which can lead to electrical problems. If the conduit is exposed to water or dust, it is important to seal it with the appropriate fittings to prevent moisture and contaminants from entering the conduit and damaging the conductors. This is especially important in manufacturing environments where there may be a lot of dust, dirt, and other contaminants present. Using waterproof and dustproof fittings can help to ensure that the electrical system remains reliable and safe. Labeling areas where conduit is present on the floor is also a good practice to alert personnel to its location and prevent them from tripping over it or damaging it with equipment. This can be done by using warning labels, paint, or other markings to make the conduit more visible. Regular maintenance is essential for ensuring that the conduit remains in good condition and that any damage is repaired promptly. This can involve inspecting the conduit for signs of damage, such as dents, cracks, or corrosion, and repairing or replacing any damaged sections as needed. It is also important to check the fittings to ensure that they are tight and that there are no leaks. In addition to the NEC requirements and recommended practices, it is also important to consider any local codes or regulations that may apply to conduit installations in manufacturing environments. These codes may have additional requirements for conduit type, support, protection, or other aspects of the installation. It is important to be aware of these requirements and to comply with them to ensure that the installation is safe and code compliant. When selecting conduit for use in a manufacturing environment, it is important to consider the specific conditions and potential hazards that the conduit will be exposed to. This includes factors such as the type of equipment used in the facility, the amount of foot traffic, the presence of water or dust, and the potential for impact or abrasion. Choosing the right type of conduit and providing adequate protection can help to ensure that the electrical system remains reliable and safe, even in demanding environments. In addition to the type of conduit, it is also important to consider the size of the conduit and the number and size of conductors that it will contain. The NEC specifies the maximum number of conductors that can be installed in a given size of conduit, and it is important to adhere to these requirements to prevent overheating and other electrical problems. It is also important to ensure that the conduit is large enough to accommodate the conductors without overcrowding, which can make it difficult to pull the conductors through the conduit and can also increase the risk of damage to the conductors. When installing conduit, it is important to follow the manufacturer's instructions and to use the appropriate tools and techniques. This includes using the correct size of conduit bender, cutting the conduit cleanly, and using the appropriate fittings to connect the conduit sections. Improper installation can damage the conduit and the conductors inside, which can lead to electrical problems and safety hazards. After the conduit is installed, it is important to inspect it thoroughly to ensure that it is properly supported, protected, and sealed. This includes checking the conduit for any signs of damage, such as dents, cracks, or corrosion, and ensuring that all fittings are tight and that there are no leaks. It is also important to verify that the conduit is properly grounded to prevent electrical shock hazards. Regular inspections and maintenance can help to identify and address any potential problems before they become serious. This can involve visually inspecting the conduit for damage, checking the fittings for tightness, and testing the grounding system to ensure that it is functioning properly. It is also important to keep the area around the conduit clean and free of debris, which can help to prevent damage and corrosion. By following these guidelines and best practices, it is possible to ensure that conduit installations in manufacturing environments are safe, reliable, and code compliant. This can help to prevent electrical problems, reduce the risk of accidents, and protect the safety of workers and equipment. When dealing with electrical systems in manufacturing environments, it is always best to consult with a qualified electrician or electrical engineer to ensure that the installation is done properly and in accordance with all applicable codes and regulations. These professionals have the knowledge and experience to assess the specific needs of the facility and to design and install an electrical system that is safe, reliable, and efficient. They can also provide ongoing maintenance and support to ensure that the electrical system continues to function properly over time. In addition to the NEC requirements and recommended practices, there are also several industry standards and guidelines that can provide further guidance on conduit installations in manufacturing environments. These standards may cover topics such as conduit selection, installation techniques, and maintenance procedures. Following these standards can help to ensure that the installation is done in a safe and reliable manner. The National Electrical Manufacturers Association, or NEMA, publishes a variety of standards related to electrical equipment, including conduit. These standards cover topics such as conduit dimensions, materials, and performance requirements. The American National Standards Institute, or ANSI, is another organization that develops and publishes standards related to electrical equipment. These standards cover a wide range of topics, including conduit installation, grounding, and safety. The Institute of Electrical and Electronics Engineers, or IEE, also publishes standards related to electrical equipment and systems. These standards cover topics such as power distribution, grounding, and safety in industrial and commercial facilities. By following these industry standards and guidelines, it is possible to ensure that conduit installations in manufacturing environments are done in a safe, reliable, and code-compliant manner. This can help to prevent electrical problems, reduce the risk of accidents, and protect the safety of workers and equipment. When working with electrical systems in manufacturing environments, it is always important to prioritize safety. This includes wearing appropriate personal protective equipment, such as safety glasses, gloves, and hearing protection. It also includes following proper lockout/tagout procedures to ensure that equipment is de-energized before any work is performed. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent accidents. If you are not qualified to perform electrical work, it is best to leave it to a qualified electrician or electrical engineer. These professionals have the training and experience to perform electrical work safely and in accordance with all applicable codes and regulations. Remember to always prioritize safety when working with electrical systems in manufacturing environments. Proper conduit installation and maintenance are crucial for ensuring the safety and reliability of electrical systems.